This should be interesting. I'm going to try that whiteboard activity from yesterday in one take, try to explain where we're going. First things first, I need to draw a heating and a cooling curve. I'll start with heating. Heating curve is going to go somewhere from down here, up, then over, then up, then over, then up. Doesn't have to be perfect. Magic numbers, 0 degrees Celsius, 100 degrees Celsius. Next thing to know is I need to go get all the little LOLs. Which ones do I need? Well, as time goes on, this is time, or it could be heat added. It's not temperature, but it could be heat added, but it can't be pressure. As time goes on, I'm adding heat, adding heat, adding heat. So I need to go get the LOLs that have heat going in. There's one of them. There's one of them. That's not one, because, as I can see right there, heat's going out. There's one of them. How many more do I need? Here's the key. I'm going to need 1, 2, 3, 4, 5. Each straight line is going to need an LOL diagram. No corner needs an LOL. Some of you would camp them on the corners. That's not something happening there. So our LOLs, there's going to be 5. So I need 2 more. And I need the ones where the heat is going in. There's another one. Heat's going in. And I need 1 more. Is this one it? No. Heat's going out. That one's not it. Is this one it? Is this one it? No. Is this one it? There it is. That's the last one. The ones that are going out. Cut. Okay, next thing is, starting at a very cool temperature, find the one with the coldest thermal energy. That would be this one. Now what you was kind of confusing seeing some of your diagrams, that goes to this whole line. Let me redraw that. This whole line is this. What's going on? Heat's going in. What's the heat doing? Heat is changing the temperature slightly, but it's not changing any thermal energy. Same. No thermal energy changes as the temperature changes. Next one. At number 2, I have a phase change, but no temp change. I have to find one with constant thermal energy, but a phase change. Furthermore, I got a phase change from, at 0, would be from a solid to a liquid, from 1 bar to 2. That's this one. So this one encompasses all of this line. What's going on at that point? Well, we're adding a bunch of heat. But as we see, the thermal energy does not change, stays the same temp. But the phase energy changes. It changes from a solid to a liquid. So energy can do different things. Can either heat things up. In some cases it does, like on number 1. Or it can simply change its phase. But it doesn't do both at the same time for some strange reason. Third one, another temperature change. So I need to find one where the thermal is changing, but the phase is not. Well, there's 2 of them. Here's one where the thermal's changing and the phase is not. Uh-oh. I'm seeing a goof up. So I just know that I'm going to fix. I don't know if that was a goof up from before. I'm going to set that one aside and figure out what I can figure out. Number 3. have a phase change, but no thermal change. This one is all encompassed. You put heat in, and it doesn't go to changing it. So I may have this goofed up, but I'm going to fix it as I go instead of starting the video over. Number 4 is just a phase change. It's this one. It's very hot, and it's still very hot. Thermal, thermal, same, same. But 2 bars goes to 4 bars. Apparently it changed from a, okay, we're on the right track again. So the last thing is, I don't agree with number 5 then. I don't think I can use this one. I think I just did something wrong when I prepared my little piece of paper. I'm throwing that out because it doesn't fit the evidence. What would the evidence look over here? Well, I know it's already hot, but it's because that's right here and right here, but it's got to get hotter. But I know it also stays the same phase, which is 4 high. 1, 2, 3. 4 high. 1, 2, 3. So I'm going from 4 to 1, 2, 3, 4, 5. When you put heat in, I'm going to have 1 more bar. I'm going to just have to make that work. So what is the energy doing? In this case, the energy that's being put in doesn't change any phase. It's already at a gas. All it's doing is going to change its thermal energy, or another way of saying that is increase its temperature. Let's see if I can recover then on number 3. Number 3 is supposed to be cooling, or on slide 3. A cooling curve is going to start high and go down to a certain point, and then a phase change, down to another point, and then a phase change, and down to another point. What are those magic numbers? 0 degrees Celsius is where one of the phase changes. 100 degrees Celsius is another one. I need, once again, 1, 2, 3, 4, 5 different diagrams. Let's see then if I really have them. Heat's going out, so I'm going to take that one. Set them down here for right now. Heat's going out. Cutting that one. Heat's going out. Cutting that one. Is there any left? There's got to be a couple, huh? There's one going out. I don't know if I see another one or if I goofed that one up and didn't. Oh, there's one. Heat's also going out. Okay. Every one of them has heat exiting. That's why it's cooling off. So number 1, it's got a really high heat, and it's going to change thermal temperature. So is there any that's extremely high, but then comes down a tiny little bit without a phase change? That looks like it is. This looked like it was like 1, 2, 3, 4.5 versus just 4. A small change, but it still changes. No phase change. This encompasses not a corner, not the top, all of what's going on this line represented there. How about number 2? Now I need to look for one that has a pretty high temp, but it stays the same thermal energy because there's no change. It's going to stay 100. The ones that I see that are the highest are this one. It's got some very high bars, 4 bars, still being 4 bars. So then what's all that energy doing? That energy is going, or is being released as it condenses or fuses together to change from steam back into liquid. So we have a change of 4 bars to 2 bars. That's all of this area, no thermal change. Next section, Now we have a temp change. Where's one that started with a pretty high temp because it looked like it was at about 4 bars, but then changed quite a bit with no change in the phase energy. Only one of the things changes. Either the heat changes, either the thermal energy changes or the phase, but they don't do so at the same time. What's left? 4. I have another phase change. Well, you cool something off to 0 and it will freeze. It will change from a liquid to a solid. It looks like 4 is represented by this one. There's no change in thermal, cold, cold, but there's a difference in phase energy as it changes from a solid, which would be 2 bars, from a liquid, which would be 2 bars, to a solid, which is only 1 bar. And finally, the last one is a slight temperature change from 1 bar to a half bar, but the phase energy stays the same. There you have it.